Ow. Say hi, Tim. Hi, Tim. Good. You're not supposed to be on this bench. But I will let you. Ah! Ah! Ow. Please do not chew on me. You goober. Ow. No, 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 no. We stop, stop, stop. Ow. Ow. Yeah, you run from this. Goober. Ow. This is my life. Ow. All right. I am going to be making circuit boards. These go into electric motors. They are Hall effect sensors. I have way too many to make and far too little time to make them. I'm going to split this up in a few smaller batches. I think I have a total of 50 here. I think I will measure out probably 25. Put the rest in the bag and we'll go separately. If I'm not mistaken, I believe these go into a medical centrifuge motor. Not 100% certain, but that's, I believe, the last application that these were used for. Alright, the rest can go aside because, as you saw earlier, I have a cat. He's only 10 months old. His name is Tam. His favorite thing to do is chew on me. Second favorite thing, chewing on my wires. Alright, so these are the Hall effect sensors. And I don't think this computer can handle 3 cameras, but yeah, microscope's not coming up. Let's see if I can force this. Nothing? Alright. Oh, so, not the greatest view. One is just have no idea what I'm seeing here. Huh. I gotta figure out the camera angle, but it's not perfect. But that is strange. This is my monitor. As you can see, it's actually two screens. It's two iPad screens side by side with drivers that accept HDMI. You can rotate, tilt, and slide on my workbench. And I don't know if that's I don't know if that's showing up at all, but basically that's one of the Hall effect sensors. Got my microscope feeding through the left screen, and my computer on the right. The camera is attached to the computer, but it's not cooperating today, so not sure why. But I can at least still use the microscope for seeing things because I am finding new glasses. Not helped by the fact that my vision is getting worse and worse as I get older. So, move these to the side. I've got to be careful with these small parts. Tam is about 9 or 10 months old, and this is probably my first time really using the workshop since I got him back in the end of May. And he is a little goober. Absolute goober. And if I'm not careful, I will lose these parts to him. So these are flush cutters. Weller now owns this company. They used to be ERAM. I don't know if that's pronounced right or not, but they are very, very good cutters. I probably spent about 120 bucks on these. That sounds like overkill, but the flush cut that they make is stupidly good. Like, I can literally run my fingernails across this where I cut the weeds, and it doesn't catch. But yeah, these are just some very precision ground cutters. I really hope I'm in focus. I'm actually going to check right now. Let's go full screen. Goodness, I can barely see this. Let's go full screen. Goodness, I can barely see this. Oh wow, that's. Oh dear. I'm just realizing how much lag there is. I'm just realizing all right how much lag there is. All right, how much lag there is. Oh wow, there's at least 5 seconds lag here. It's gonna be really hard to adjust. This is helped by the fact that looking at this on an iPad screen. Looking at this on an iPad screen. Okay, that screen is a little bit easy to look at. Sorry, no latency. Honestly, this is mostly me just experimenting. With the new setup. It's not easy to adjust with the lag. If I were to do this all again, I'd buy cameras that focus motors. Oh, that's much better. Should be able to fine-tune that. Oh, my neck does not like that. That was about as good as I'm gonna get it. That'll do. Split that. All right. So, one down. There's a few different stages to this. Obviously, right now I'm inserting Hall effect sensors into the board. These aren't terribly complicated, which that's not bad. But yeah, I can actually get a flush cut by just sort of pushing on the part, closing the flipper, and then snipping, which ain't too bad. After the parts are inserted and clipped, I'll apply a little bit of flux. These are very tiny through holes, so the flux does help ensure that the solder wets properly. Speaking of solder, I just realized I didn't have my solder. Oh, right there. I just ran out of solder at work, and I brought my supply there so that I could continue working. I have a heavy recliner as a work chair. The back legs are quite literally jacked up with extensions, so it doesn't actually recline, it actually leans forward a bit. It does make reclining a little difficult, but it is possible. But with it, the angle altered, it works. Works far better than it has any right working. So this is just kind of a bunch of repetitive work, but it is work nonetheless. It's something. Ideally, I would work several hours on these and get a bunch done. I'll see how far I go tonight with this. Part of the issue with these is I've just not had my workbench set up for quite some time. This is honestly the first time I've sat down at my workbench and actually done actual work, probably since before I got my cat. And he's just been a little ball of chaos. I think at some point he'll probably come back and visit. So you might get cat on screen eventually again. Alright. Going to move my trash a bit closer. Oh yeah, need this on here eventually. It's kind of dirty, but whatever. I'll use that when I do the soldering. Dump the leads in the trash. I do not need to be stepping on that. I'm going to do something here. So one thing I don't know is how my sound levels are. Hopefully they're not too bad. And I was talking like this, it's peeking into yellow. Just getting a little bit of background going here. I kind of like the Skyrim nighttime rain music background, so I don't know if that can be heard or not, but yeah. I also have a beam extraction fan going. Very dusty, but there's a carbon filter in here. That's just to keep solder fumes down. I did set up a noise filter. I don't know how well that works, but we'll see. Prior to this, I have quite literally done all of my streams using a recycled iPhone 6S. I've just hung it up at the top of the bench, literally using some tape, and that worked, but it was very glitchy. And I guess I'll see how OBS handles things. I've got an old laptop here. I'm using that instead, seeing how well that works. Yeah, I'm just trying to figure out why it's having so much issues with my microscope camera. Yeah, it doesn't even want to bring it up right now. I'm going to try killing that. Like that. Let's see if it'll at least load. At the very least, see if I can get still out of it. No idea why it's behaving this way. I can see it on my screen. Anyway, not gonna question it too much. It works, so. You can smell cigarettes outside the window. Lovely. I recently have been putting together a bunch of recycled computers for the purposes of running folding at home. And I realize I never set a screen share. Whatever. Oh, hi, Tam. Alright. So, right now, getting about 4.7 million points per day running folding at home. I have a few systems running, just a few. Two of them have GPUs. One is a 980 Ti, the other is a 1660 Ti. Not like new or impressive graphics cards, but just for, having, a little extra processing. They work. It's not a super efficient setup, but that's okay because I am not running any heat right now. I am running literally just the heat off of free medical research. So that works for me. So yeah, I really need to set up a screen share. I am literally aiming my screen at my camera. Sorry, I'm just adjusting my view. Alright, cool. I typically upload these videos to YouTube after I'm done streaming. Mostly just as an archive. And again, like I said, this one is just kind of more of a camera test and an OBS test. This particular setup is entirely new. I have a much better system lined up for handling this, but it's one of those cases of ambitions gotten in the way of, actually setting it up proper. So I do have a print for these. I'm gonna leave that off camera because, proprietary stuff, I'm sure. But it does show the proper orientation. These, there's kind of a flat side and a side that has the edges rounded. The rounded sides go toward the middle because that is the direction they are most sensitive to magnetic fields. At the center of these would be a rotating magnet assembly that has alternating north and south poles, and as the shaft of the motor rotates, these will detect either north or south poles in a particular pattern, and that pattern lets the motor know exactly what position the shaft is in, and that allows it to determine which stator winding to operate in which polarity. These are for brushless motors. There's no physical uh, commutation contacts inside. They just use these sensors, and then they electronically switch the windings in the stator. So that electronic switching creates basically what amounts to a rotating magnetic field. The shaft has permanent magnets, and those magnets are then dragged around in this rotating magnetic field. What's nice about brushless motors is they're very controllable. With the right sensors, you can have them rotate very slowly, or you can have them run at full speed, and it's all electronically controllable. DC brush motors have physical contacts that transmit the electricity onto a rotating piece with different plates that conduct. And each of those plates are then attached to different windings, so that as the motor rotates, which windings are connected change contact, and then you have magnetic field constantly adjusting. They can have their speed adjusted, but especially at the low end, it's hard to get precise control. So brushless motors have just much better control over their speed. And I've always said I kind of wish model trains would incorporate brushless motors. Most of them use just some old cheap DC motors, but I do not want to knock anything over. This, I know this has electronic controls. This is one that I custom painted decal. But if you look inside, you can see that there's actually an electronic control board in there. This thing has sound, digital control, actually transmits the signal through the track itself. Yeah, I've always kind of said I wish they would do brushless motors in these. That would give incredible speed control. A lot of these, the real impressive trick is not how fast can they go, but how slow can they go and still be under control. Tam, what are you doing? I can hear him doing something. I think he found himself a grocery bag and dragged it over here somewhere. goober. So eventually, after all these Hall effect sensors are soldered into place, um, so I'll use this flux. It's just liquid flux dissolved in isopropyl alcohol. Got a brush that I'll use to distribute it over the circuit boards, over the leads, and that helps to that helps to that helps wet the solder, kind of dissolve contaminants and let the solder wick into the small spaces of the groove holes. Caleb, what are you doing? Like I said, he's a goober. Not sure I want to be calling him, but I can hear the bell on one of his toys. He's having fun. And if I give him long enough, he'll come and bother me. And there, he's got zoomies. Oh dear Lord. Yeah, if I must, I will very quickly put something over all of this and secure it from the little kiosk gremlin. I have no idea what he's gotten himself into. I can hear him plundering. Okay. And I don't know if that's coming through even, because I said I have noise canceling turned on. Boy, he is making some noise. It's nice when the leads line up, but now and then you get one that's just kind of bent out of shape and you gotta straighten them out. I guess if anything, it's a good record as to how long it takes me to do these. Although the talking doesn't exactly help. These boards are simple, but it's all kind of finicky work. It's low enough quantities that it probably doesn't pay to have some place manufacture them. And on top of that, they have standoffs pressed into the boards, so they probably wouldn't fit through automated machinery anyway. So yeah, these are just kind of low volume, handmade type things. I have a tester. Got another one I made for at work too. This one's handmade. My other tester is actually my first circuit board designed on computer. But this thing has positive and negative 3 Hall effect sensors. These lights just indicate whether the sensors are turning on or off. I'll run a magnet through each of these. I test 100% of these. When they have the right signals, I can reset this fault switch. If I do a rotation, this should not turn on. Though it always turns on when you have nothing connected or if it's partially connected. So normally I would be letting this computer run folded at home as well, but since I'm letting it run OBS, I'm letting it relax. It's only using 12% of the CPU, which ain't bad. I kind of wonder what happened. Oh, I see. The microscope feed was on, so it's just simply straight up not working on the computer. Yeah, I'm not sure what's up with the microscope camera. It's technically supposed to be a 4K camera. It's, AliExpress 4K, so I don't know how accurate that is. But I've got it plugged into these iPad LCDs, and the problem is they use a weird resolution, 2048 by, I think it's 1536. It's like a 4:3 ratio, and it's not a standard 4K or 2K signal. And so, of course, the camera, despite it being 4K, downscales all the way to 1080p. And that's what I see on the screen, which is very frustrating. I mean, I suppose if I were using normal screens, it would just work. But, that's what I get for using weird resolutions. But yeah. So when he's finally calmed down over there, I'm dreading the moment he decides to leap up here. He's never seen me work here before. The past 10 months have pretty much been other things. October, I do tech support, and PC repair and things like that at my main job. The Windows 10 end of life was hectic. I was a bit busy then, so I weren't messing around with anything over here at my workshop during that time. That's all calmed down, thankfully, but it was a lot. Yeah. Gosh, boy, how many machines do I have here? So my just realized my microphone is the speakers. I really hope I'm not blowing that out. I'm going to keep that very low. Very, very low. I am going to do something here. I am just enlisting some ears. don't know if I'll get a response here, but yeah, I just want to make sure I'm not blowing out the sound here. I just realized my microphone array and my speaker array are the same thing. So even though my audio level might be low, it's literally coming from the same device, so I may have been blowing out the sound this whole time. We shall see. I don't see it being picked up much on noise cancel. Oh, that would be fun. Oh, that's too fun. I think it is noise cancel. I suppose I should have realized that was going to be a thing. I don't know if that will pick up or not, but we'll see. Oh, all right. I'm going to mute this entirely. Hello? How do I sound? Okay, how does this sound? All right. So I'm wondering if I was completely blowing myself out before with this audio. So what does this sound like? Are you able to hear me? That's what I expected. What does this sound like? Is the music even audible? Oh my goodness, that is so low. What percent even is that? I'm not sure that's. Oh, I know how to tell. 3%. Wow. So this is 3%. It My audio is literally one of these little speakerphone sound bars. It's like a little Dell piece. It occurred to me the music and the microphone are the same device. So yeah, the whole start of this may be completely useless. Well, I wasn't running the music the whole time, so the only thing I don't like is I can't hear it now. That's funny. Oh, that's what this is. This is all testing. So, all right. I'm kind of surprised how quickly this step is going. I mean, it should go fast. I mean, normally. I probably wasted more time with testing the setup than doing things here. But, actually, Oh, okay, there's the timer. So I've been going about 50 minutes here. That's not too bad. So I actually, when I do these, I have recorded times that I know what I typically do, and that's what I essentially bill these at. I will oftentimes play YouTube videos or music or do other things, and so I don't have any concerns about if I take longer to do them, I'm not going to be, inflating my time doing that. It'll take me longer, but I'm just wasting my time, not the actual work time. Because, like I said, I've timed all these things out so I can pretty much tally it up by number of units times time, and I know what's fair to bill. So that way I don't feel any issue with basically messing around like this. So I think that's a fair way to handle it. Because otherwise I'd be constantly kind of trying not to get distracted, and yeah. Sometimes it's a good thing, but sometimes I just want to sit back and relax and do some soldering. I actually just enjoy this. I'm shocked that the goober has left me alone. He must have gotten bored with me constantly taking him off the bench. Yeah, you missed it, but the stream basically started with me holding him on the bench on his back, petting his belly, and then being chewed upon. Because that's just, what happens. And I know you know the story, but, should a soul stumble upon this stream someday, or the VOD, Tam is part of the cat distribution system. My sister's best friend was gardening, and this little fluff ball pops out of a bush and approaches her, and she decides he's the cutest thing ever and starts petting him, being nice. And once, her being a nice human was established, the rest of the litter came out of the bush. 4 in total. Took her a month to home all of them. I got one of them. Tam absolutely chose me. He saw me, he immediately approached me and was cuddly and adorable, and that decision was made. I had no part in it, but I was happy with that decision. That happens sometimes. Eat. All right. I usually do have a few spare Hall effect sensors in case, they're swallowed by the void. I really hope the void doesn't swallow any of these, because now the void is corporeal and fluffy. But no, I do keep a supply of a few spares just in case one hits the floor like just happened. I actually don't recall if I had 2 installed or 3, but that's no longer an issue of the present. So I'm actually kind of shocked how quickly this is going despite my distractions and messing around. I suppose the other thing I should ask is, how's the focus look? I know I had some troubles before trying to adjust the focus with a 5-second lag and a hair trigger ring. I just realized something. I should figure out a way to incorporate chat into the screen. I'm gonna have to look that up. I think it's just like a window capture. Wow, I'm sure there's plugins that can do it too. I've done in the past where I will literally just screen record the VOD with the chat incorporated into the view. It's very, very low tech, high tech, but it works. I have a VOD that I need to get put back up, but I need to edit it because I realized after the fact that my bags of parts all had my personal information on, so that VOD is not up. It has not been up for well over a year. I was messing around with, I don't even remember what the name of the application was. Has a really nice tool for like tracking things through the video and applying a blur over it. And I got the whole thing done, and it didn't save the changes. I spent hours tweaking that, and it didn't save the changes. I have no idea what I did wrong, but that was frustrating. I may get all these soldered tonight. Oh. So this is half the batch. I am going to work in half batches because I dumped my waste leads into the pile of parts. Excuse me. I am going to acquire caffeine. This stuff is tasty. It is a mouthful. Zero sugar Mountain Dew Baja Cabo Citrus. I feel like this should be the title to an isekai. But it's tasty. It's kind of a citrus punch sort of thing. They had it last year. I found it. I bought some. Very much enjoyed it. And then went to buy more and found out it was discontinued. And this frustrated me greatly. But they have brought it back a year later. I hope it sticks around. I like that they have a zero sugar version of it. I do not buy sugared versions of drinks. Even my regular bottle, my capacitor flask, um, even the drinks that I mix with that are all sugar free. I don't add sugar if I don't need to. I got a buddy who actually probably, I don't know, I won't discuss that. Anyway, those are all ready for soldering. Well, flux first, then solder. Alright, so this is my Hako. I don't know what that number is. Well, it's a Hako 936 base station, I think. It's either 807, 827, I forget. I've had that since 2004. It's the original heating element. I have done soldering sessions that have been full work days, 8 hours, 10 hours, 12 hours, even 18-hour sessions. I once left it on for a week and didn't realize it was on. It is still going 22 years later. This thing is a trooper of a soldering iron. And the only times I've ever had issues with it has been when I used non-brand tips. The cheap Chinese tips are truly not worth it. I can vouch. Genuine tips really do make a difference. The cheap ones are just not built to the same standards. I bought a hot air rework station, and it's an AliExpress special. Nothing terribly fancy. This is the soldering iron that came with it, and I don't know if you can see that, but here. I don't know if you can see that, but it is very much not straight. The actual tip inside has a curve to it. It's the same general design as the Hako. It's just built to such low quality that it's almost inconceivable how bad it is. I do not use it for soldering iron. So I do not use it for soldering. I use it exclusively for, like, if I need to melt some plastic or something. I don't use it for anything that I need to actually work. My Hako is reserved for actual soldering iron. This tip is actually really old. It's several years old. I should probably order new ones, but it works. It's one of those things where if it ain't broke, don't fix it. So, because the through holes are so tiny, I will add flux to help with the solder actually flowing through the holes. And it really genuinely does help a lot. I probably have my head in the camera. Sorry about that. Oh, hello. Hi, Tim. keyboard. Oh no, 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 no. Don't step on the keyboard. Hi, buddy. Kitty. Hi. This is my life. You are adorable. Kitty cat. He's a good boy. Nope, nope, nope. You're making me a liar. You are a goober. You know that? Ah! Nope, you go down. This is my life now. Yep. So I don't want him to scatter these parts all over the place. So hopefully he'll behave. Oh, where did I leave off? The flux gets washed away later. So if there's extra, it's not a big deal. Um, that's not my concentrated stuff. Huh. Suppose I was moving things around. I have no idea where I put the rest of my flux. Alright, it's here somewhere. It's usually much darker than this stuff. I literally just had it. I have no idea where I put it. It's usually much darker than this. This is actually diluted with isopropyl alcohol, and that helps it flow better, including flowing into those through holes for the leads. And the alcohol actually evaporates, which leaves the flux kind of deposited everywhere, but without it being so liquidy after the fact, which works well for soldering. If I solder too quickly after applying it, it'll, very rapidly evaporate the alcohol, kind of hear it boil off. There's no harm in that, but it just does take a little extra application of heat to do that. So usually I'll just apply all the flux in one go and then come back to do the soldering. One thing about soldering these is I will solder the top first, usually one lead, to secure the parts in their proper place. And then I will flip the boards over and solder the bottom. The bottom's important because, and it's also the reason I trim them with literal $120 clippers. They are flush cut trimmers. They have an incredibly precisely ground cut, and they cut so that one surface is completely flat and all material is pushed away in the opposite direction. and that lets me get an incredibly low profile surface. Um, that is because when these are mounted, they can't hit anything beneath, or they'd risk shorting. So we don't want that. So when I solder them, I'll flip them around after securing each part, and I make sure the other surface has a very low profile solder joint. So this stuff is lead-free solder. It is 96.5% silver, 3% copper. Oh, no, I take that back. It's, yeah, that would be expensive. It's 96.5% tin, 3% silver, and 0.5% copper. It has, this is Kester, which is kind of a name brand. This has the No Clean 275 flux, which we still clean. It's just that for most applications, you don't need to do that. Like I said, think I think these go into medical things, so we do some very precise following of the instructions, so everything is all up and up. Like I said, these all get pretty much handmade. So right now I'm just kind of tacking single lead, doesn't need much. But that keeps the part secured. Then I can flip them over and solder the bottom. They'll all get visually inspected. I actually shine a light through each board to make sure there's no solder bridges. And if any of the tops don't fully flow through from the bottom, then I will flip them back upright and solder whatever leads aren't fully flowed through. Usually they'll flow through, but sometimes they won't. When soldering, it is important to have fresh solder and flux. Um, there are certain things that can happen when solder gets hot, which can cause it to just not work as well. Solder can kind of almost like crystallize or something, and a lot of times you'll see that as like residue on the tip of the soldering iron itself. If you can see, there's a part that's silver and a part that's not. And the part that's not originally would have gone all the way up to here, but over time it's built kind of a residue over the top, and it doesn't, the solders, it doesn't stick. So that's a good reason to get new tips now and then. Right now, since I only use the very tip of this, I'm fine with this amount left, but eventually, that'll get less and less, and I'll want to replace the tip. really need to get new glasses too. I used to have no issues with really near vision. I could literally hold stuff up right in front of my eye and just work on some of the tiniest things. I cannot do that anymore. Um, my near sight is now starting to diminish, and so I need a lens to see like close, and I need a lens to see anything past about here. So I have a very narrow window of what I can still see without glasses. And these ones are kind of out of date, but they are better than nothing. The bottom isn't bad, but the top, these are kind of, oh, hey, buddy, you cannot come here while I'm soldering. That's hot. That'll hurt. I am, I am petting him. You can come here if I hold you. You can come here. Come on. Come on. Immediately goes for the small parts. You, you are a goober. You are my little house gremlin. Little stinker. All right, let's see if I can. Nope, nope, you are chewing me. I don't like. Ow! I don't like that bite. No, little stinker. Oh, you little stinker. Of course, he is in like just the worst part where he can chew on me off camera, so there's no evidence of the crimes. Let's try to climb. Oh, okay, that's not gonna work. Okay, he's on the floor. You are a little goober. All right, that's unfortunate. He jumps up this way, so his face is over here, and the camera gets the unphotogenic end. And if I try to rotate him, I will be bitten. He chose me, I think, because he likes the flavor. I don't know. Little goober. All right, so I think I was, yeah, here. There is no winning. At least he's adorable. He is surprisingly social. Every cat that I've had just likes to stick to family, that sort of thing. Him, his first time at the vet, he was licking the vet while he was getting his first shot. He is just really friendly, and he's friendly to me, but he also likes to chew on me because he knows he can get away with it. Because I am not tough on him because he is my little goober. So yeah, it's probably my own fault, but how can you punish that little fluff ball? Honestly, if I do any type of punishing, the result is usually I get bitten for having punished him. I got a little squirt bottle, the usual stuff, and he is a cat of vengeance. He remembers that. So the other issue with squirt bottle is he really likes my wires, and wires and squirt bottles don't pair well. So usually I just have to stop everything I'm doing and chase him away from the wires because, that's my life now. So it's a good thing he's cute. So far, he hasn't turned himself into a crispy cat. So far, so good. Mainly, he doesn't mess with any wires. It's just the wires to my computer because I think he just knows that those are the wires that, will get the most reaction out of me. He's shockingly smart for how shockingly dumb he is. And yeah, like I was saying earlier, I've got a print that shows, how all this goes together, so I'm not just doing it by memory. There's actually a diagram for it. There ain't much to have to remember, but it's the orientation of the parts, the side of the board that they mount to. After these parts are installed, the next step, obviously I still have to flip them and solder all three leads from the bottom side. But then after all these are mounted, the next step is actually connecting lead wires. And I may have to just close the door for that because I don't think there's any hope of not being messed with while I have 18-inch wires of 5 different colors dangling all over the place. I'm doomed if I let him in this room while I do that. So that won't end well, I'm fairly certain. So yeah, these aren't particularly complex circuit boards, but they serve a purpose, and it's a check. And I am almost done with this step. Got the fan turned low enough that it's not too loud, but high enough that it gets most of the smoke. This far away, it's not quite getting everything. So I'm just going to rush through this. I recently picked up a few air purifiers, and I've been thinking about setting up a bigger fume extractor. Specifically, I'm thinking of maybe setting up one with a bigger fan in a box with some soundproofing, and then run a hose up to the workbench. Because this setup has the fan directly behind the filter, you know. But if I put the fan in a box, have sound dampening on that, then have baffles kind of block the sound coming up through like a hose, those tend to work pretty well. And they're not hard to make. I just got to do it sometime. Alright, so every one of these boards can be flipped. So I will apply more flux to these. So I want the bottom to have a good supply of flux. Alright. And this is actually an area where I don't mind applying extra flux because I can actually apply it to all the lead holes here. So it's actually kind of ready for the next step after this. So I just kind of knock out, you know, 2 steps in one go. So these holes spaced wider apart are actually where the wires end up going. They mount from the bottom side of the circuit board, so the side that's showing now, and they solder on from the top. So just applying flux on this side now just makes sense. So I'll actually get every single one of those holes applied. And like I said, all these get washed. I don't mind if a little extra flux gets on them because it's all getting washed away at the end. I don't mind if it goes on heavy too. That just ensures that I have good coverage. I did try flux pens many, many years ago, and I found that I don't like them. You spend too much time just trying to get the flux to flow through it, and I just didn't care for them. It was a name brand one too, so it's not my thing. I'm also realizing Where did I see this one? I didn't trim these flush. I got them close, but not flush. I don't know if it's even possible to see that, but I didn't hold this part down all the way. You can kind of see the edge of the leads. Even though this one is already soldered, this clipper will make short work of that. So as you can see, just completely flush. All right. And that's, that's where visual inspection matters. I think I need to actually clean this tip a bit. It's off camera because it's literally stuck to the top of my soldering station, but I have some fairly aggressive tip cleaner. You basically melt the end of the tip into it, and it just really aggressively eats away at any residues that might be forming. It's harsh on the tip, but you know, it works. Eventually, I'll just replace the tip. Okay. And this is where new glasses would really be nice. One of the nice things about a good layer of flux, say I solder two of these leads and I bridge solder between them. With a good layer of flux, usually the solder will bead up on each joint and separate. Not always, but it usually does. Try not to keep heat on them for too long. Obviously, those high temperatures aren't great to keep on a component for very long. So I usually just try to apply heat for only just long enough. This is actually, it's working actually. Without really getting my head in the camera. This one might bridge. I don't think it did. Oh, this is actually somewhat difficult. I am actually having a fairly hard time seeing this. Oh, yeah, that's one of the problems with flux. It is quite sticky. So if you see me keep pulling these off the workbench and putting them back on, it's because they stuck to my arm. I'm going to do these a bit closer. This actually is proving to be kind of difficult for me vision-wise, because these glasses are not perfect. So trying to do that last row is not working well. So hopefully, oh my goodness, you can't see it because the microscope camera isn't behaving, but I forgot my microscope screen works just fine. Still not quite accustomed to it. Suppose given enough time, I should eventually become accustomed to using it. I think my biggest issue with it is, since it's just a monocular microscope, it is difficult to tell depth. Suppose over time I'll get accustomed to it. Oh, and that is, I see you. Gotcha. Well, at least I can inspect them with a microscope. Yeah, this is kind of the part that I worry most about. I do not want him jumping up here while I'm soldering. That's a recipe for disaster. See if I can. Okay. Okay. I'm not going to complain about that. Aside from one solder joint, that was all done by microscope. Maybe I can make this work here. I that is a hard habit to break, not looking at the part, looking at the screen instead. This is an interesting experience. See now there I just kind of missed the, the actual part I was soldering. I bumped the solder up further up the soldering iron tip. Again, I don't have good, well, I don't have depth perception. I just put the solder under the circuit board there. But once I find the spot, I can just kind of drag it along and it works. It's going to be one of those things that over time I'm just going to have to get accustomed to. I've been used to just doing that anytime I needed, and that doesn't work anymore. It's kind of it's unfortunate, but that's life. Let's try another one entirely with the camera. Sorry, I gotta stretch and crack my bones because, getting old. And I'm staring at the board again. Now I get a little silent while concentrating on this, but it's a fairly new experience for me. Trying to look at a screen while I solder instead of directly at whatever I'm working on. I I really wish the microscope view was working. I don't know why it's not. I force it. That just does not want to go. Can I? Just see if I can restart it. And it comes over HDMI just fine to my screen, but the computer just doesn't want to pick it up over kind of messing with the cable. Maybe there's something up with the cable. I don't know. It would be nice if it worked, but oh well. I honestly, I like this microscope. It's got a good picture. Um, Problem is it's so difficult to adjust. and it doesn't quite cooperate with this screen. The aspect ratio is squished because the screen is 4:3 and the camera is, of course, widescreen. So I don't know, it's not a perfect setup. I was hoping to get 4K to the computer and then be able to record those streams, but I pretty much know this computer's not going to do it. I've got another machine it literally runs, but it, it's buried behind my other work desk, and I need to straighten that out, and I need to install. Let me grab I need to install this for my sliding monitor. Well, I've got another one that's got cables run through it, but that's basically what this is. It's a cable chain. So it's able to move, and it smoothly guides wires. This one's empty, but I have another one somewhere which has all the wires run through it. I need to install that up along the top of the workbench so that I can have this monitor be able to slide and move. Then I've got these HDMI splitters as well as switch. And the goal with all these bits and pieces is I'm going to have two HDMI signals coming from the computer, hence the two inputs going to two pair of outputs. I've got more of these little iPad monitors built up already. I actually built these in a stream, and that VOD does exist on YouTube, I believe. But I built those screens. I want to set those up on my work desk over to the side of me here, and so that I can see the same thing on both screens. But then for this bench, the left screen is going to go through this two-way switch. So I can view the computer on both panels, or I can view the microscope and one screen of the computer. And that way, I'll just have a little bit of flexibility. I'll be able to run the microscope, obviously. But I'll be able to have the computer be on the work desk or the workbench here. And I've got another pair of monitors there. It's a weird resolution. I have nothing but weird resolution monitors. 2048 by 1536 for these iPad displays. Then my other monitors, I believe they're 23-inch monitors, 2048 by 1152, I think it is. Yeah, they're weird monitors. They're just a little bit more than standard HD, but they're not quite 2K. I've had them for years, but I'm just gonna grab another splitter probably and have one monitor face this way, and then probably literally have the other monitor right behind it facing that way. So I've got at least one big screen that I can look at too. It's a lot of little setup and running cables, and I'm gonna have to, all these different devices run off of pretty much, this one's purely a mechanical switch. What? Okay, cool, interesting. But the other ones run off of USB, so I'm just gonna get like a USB power supply, um, and just have that run all the different devices. Likewise, all four of these little iPad screens run off 12 volts, so I'll just have a 12-volt power supply that runs the LED strips. I do plan to put LED strips along the bottom edge of the screen just for extra illumination. And so between these screens being powered off 12 volts, the LEDs being 12 volts, I just want one power supply to run everything. So LED strips, the little iPad screens. There's no reason to have 10 million bricks when I can just have like one power supply that, you know, outputs everything. In fact, if I do it right, I could probably even make something like a USB power distribution box that is just powered by a single supply that puts out 12 and 5 volts. Probably even use like an old ATX power supply for something like that if I wanted to. Um, though that being said, I do have, I do have a proper dedicated power supply that just generates 12 volts. So I'll just have this run all my 12-volt devices. Wow, that's dusty. This is my soldering iron calibration device. Just lets me verify that my temperatures are correct. All right, that is a hard habit to break. I really want to do. Oh, what are you doing, buddy? Doing it again. All right. I can look down to pre-position things. That does kind of help with setup, I suppose. And then I get that when the solder don't want to stick. See, now that there was a bridge, but it broke up right away. That's something where having the extra flux really pays off. Solder gets almost, I don't know what's a good way to describe it. It's almost like more viscous. Like, it's not viscous in that it's like molasses or syrup, but more like when it touches things, it has more surface tension. When solder is kind of when there's no flux, solder has more surface tension and wants to just stick to every little thing it touches, and it doesn't want to flow. The flux, though, helps burn off oxidization and other contaminants, and it almost acts like a way to clean the surface. And that helps the solder flow into the little nooks and crannies, like we want it to. I am starting to get used to this, which I am grateful for, because I'll be honest, I've had a lot of projects I've not worked on for a long time because in the past 2 years, my vision's just been getting worse. And it's really frustrating. It's just something that happens with age. And I am finding ways to adapt around that. This screen helps a lot. Of course, it's funny. I settled on a tiny 10-inch or 9.5. I forget what size these iPad screens are. I settle on these tiny iPad screens, my primary display technology for my workshop, right before my vision starts to go downhill. Go figure. They work nicely. Like, I don't know if this is okay. You can kind of see the screen off the edge of the, you know, corner view here. Yeah, these screens, I made these screens. They are fully handmade. I don't know if that's showing on the camera now. It would help if I move it in line with the camera. The case is literally just layers of polystyrene plastic from a backer for a GameStop poster panel. I used to work at a GameStop. They had these polystyrene backers for the posters. There would be like a plexiglass front, a polystyrene back. You put the posters on the uh, plexiglass over the top, and there's these little kind of round nuts that would hold everything in place. This is literally just that backer. I can cut it with an X-Acto knife. It's really soft, but it's got just enough sturdiness that it works. Um, and I'm trying to find a way to flex this without stretching cables or breaking anything. Yeah, it's literally layers. I cut out the pattern, screwed each layer onto the previous one, and that's how all of it's contained. I really need to get the power cord situation dealt with on this, because that is a pain. I've got the power cord literally just wrapped around things on the middle shelf of my workbench, and it's not it's not great. I also can't move this very far without unspooling more power cord. Um, which I have now unspooled and cannot get respooled. So that's another project that will be significantly helped by getting the cable chain installed. Once the cable chain is installed, then I don't have all these wires hanging around every which way. Once the cable chain is installed, I'll also be able to wire up my primary computer that I built for this whole task that's currently sitting idle. It's an older system, so it's basically all built with like used and recycled parts. It's an i9 10th gen. It's got 64 gigs of DDR4 RAM, so silver basically. DDR5 is gold these days. Um, it's got a Radeon 7 GPU, not the newest GPU. It's probably from about the 2000 series NVIDIA era, 2019-ish. It's ironic though because NVIDIA NVIDIA nerfs their gaming GPUs for compute because they want to sell high-end compute GPUs to like data centers and stuff. So they actively limit the compute performance of their gaming GPUs. A buddy of mine got a 5080 recently, and that's what, last year, 2025. My 2019 Radeon 7, like the 5080 just leaves my old Radeon 7 in the dust, except in two areas. The memory bandwidth on the Radeon 7 beats the memory bandwidth of the 5080 just barely. The 5080, I believe, has, what was it? I was just talking about this earlier, actually. What was it? Okay, so the memory bandwidth of a 5080 is 960 gigabytes per second on a 256-bit bus. The Radeon 7, which is like 5, 6 years older, has the same amount of memory, 16 gigabytes, but it's high bandwidth memory, HBM2, with a 1024-bit bus. Oh, no, it's a 4096-bit bus and a terabyte per second of bandwidth, 1024 gigabytes per second. So it actually beats the 5080 by just a small margin. 1024 versus 960. And then here's where the Radeon 7 really shines. And since I do folding at home, I do, heavy compute during my idle, CPU and GPU times. Um, the floating point 64 compute capacity of the 5080 is 879.3 gigaflops. The compute for floating point 64 on a Radeon 7, 6 years older card is 3.36 teraflops. Point 0.88 teraflops versus 3.36. That's how much NVIDIA nerfs compute on their consumer cards, because they want to make their high-end data center cards worth that much more. Like, I get why they do it. They can do that. That's their choice. But, that's kind of nuts. But yeah, so I'm looking forward to getting this Radeon 7 added to my folding at home army. Um, that's kind of one of my. I've never been into the so-called clicker style games. I know some people dig that. I've never been into it, but this folding at home is kind of my clicker game. They have leaderboards, and I like seeing number go up. It's my one number go up kind of guilty, you know, actually not very guilty. I'm doing medical research for free. So I just like the idea that, you know, if I have old machines that I'm recycling, or, you know, my own main machine, um, that's stuff that I can put towards a good cause, you know? Nothing nothing bad about doing medical research. Last month, my average points per day was about 600,000, and I ended up installing Linux onto a bunch of machines. I added some new, not new machines, but new old machines, basically salvaged recycling stuff. You know, not cutting edge, but good enough to do some work. I put together additional machines, put Linux on all of them, set them up to do folding, and now my average score is, where is it? I'm getting 4.7 million right now, which is quite an improvement from 600,000 literally 2 weeks ago. Um, it really goes to show just how much performance is on the table because of GPUs. I only have two GPUs in my entire setup. An old 1660 Ti and an old 980 Ti. Between those two GPUs combined, they do 3 million of those points per day out of 4.2 to 4.7 average. That's kind of wild. Hi, Tim. Don't bite me. He likes to bite me. It's not usually like hard or vicious. He just likes to chew on me, and that's how he lets me. Oh, that's cute. Oh, you got zoomies, huh? He's not gonna cooperate. I I am really fighting that urge to stare down over the parts. Sometimes just getting that initial heat transfer going is the hardest part. Once it's going, it usually will work fine. I think I have the angle of this wrong. So that's every soldering iron I think I've ever seen sold comes with a conical tip, and I think that is the worst possible tip choice for a soldering iron. Conical tip is almost niche. Like it's good for very specific things. I always go with a chisel tip. That is my preferred setup. If I need, now it's hard to do with this tip because it's so old and worn, but if I need a narrow tip, now I have a narrow tip. I need a wide tip, now I have a wide tip. Actually works pretty good. Wow, that hour and 20 minutes went by very quickly. Probably get these soldered up and finished and probably call it there. Help if I actually use the microscope. No, this isn't the. Yeah, I'm using the microscope. You can't see it. That's frustrating. I think a lot of my issues will be solved by having the more performant computer, but I'm not sure. Some of these issues might be because I'm running a weird resolution monitor off this camera, and I'm wondering if that's causing issues. But then again, it could also be a bandwidth thing. Though that said, I don't see any issues with my main camera here. It is running off the same hub though. That is a little bit of a concern. Um, what is the bandwidth requirements of 4K? All right. Okay. And a single USB 3 should be able to handle it, but it's all going over one cable though, so that is a little bit of a concern. I wonder if it's just bandwidth. I don't know which of these USB ports on this thing are, if they're separate hubs internally or if they share or what. But regardless, this computer is only temporary. It's just a laptop I typically take with me to work. It's not new or anything. It's only 8th gen i5. It's a nice laptop, it gets the job done, but maybe 4K 30 is too much when there's already a 1080p stream on the same USB. I don't know. I've gotten it to work, but not always, and it usually ends up in the long run just freezing. And lately it's not even loading, so it's possible maybe something crashed. I don't know. But I really don't want to force this to stop in order to make it appear. I'm going to try deleting this entire scene. Add a new one. Oh, Okay, interesting. We got something. Of course, it's frozen, but this is what I'm seeing on my screen. So the right or the left screen, I'm able to see this, which is nice. Um, this is actually a lot more visible, but you know, obviously you can see I'm moving and this stream is frozen. So it is what it is. Hide it, show it, you know. This is what it should be doing, except it should, work. Um, but yeah, maybe I will get this figured out later on, but for now, just pretend this is a moving picture. That's what I see. So, but yeah, I can actually see this just fine on the LCD screen over the HDMI output, but it's just the computer does not want to cooperate with receiving it over USB-C. But I'm pretty happy with how this is turning out. This batch will be done pretty soon here. Click that. Yeah, still frozen. I don't know why it's having so much trouble. Oh, interesting. It worked for a split second there. Yeah, I just think this computer can't handle the strength this thing is putting out. I think it's overloading and it's failing. But at least it's some progress. I had a moment of which screen am I looking at? See there, that's okay, nothing goes in that hole, so it's not actually a problem getting some solder there. Just smooth it out. These holes get the lead wires. And I hate to lock the little dude out, but he's never seen me solder before, and I have my doubts over how he'll react to stuff like this. That's not, that won't end well. So I will definitely need to lock the little house gremlin out of my workshop here for my own sanity and his own protection. So far, he's not jumped up too badly. Nothing I couldn't, grab him and make sure he didn't, touch the soldering iron or something. I really don't want him to have to learn the hard way that soldering irons are hot. That would suck. The TAM has had issues with jumping on the counters. I don't like that, but my main concern is the stove. He's not hurt himself, but I don't want him to risk hurting himself. So I've been trying to keep him off of there. I definitely use the squirt bottle in that case. Well, this is pretty good progress so far. You know, this computer is actually not working that hard. I'm only using about 9% CPU. 58, 6,500 kilobits per second. My internet isn't great. I only have 11 megabit upload, which technically should be enough to stream, but at least when I used the iPhone, the ancient iPhone to do it, I had really, really glitchy streams. Like lots of video artifacts, stuttering, and I suspect a lot of that was the phone itself just not working well with keeping up with the data throughput. Um, I haven't seen anything bad with this stream, but then I also don't have it open in another window either, so for all I know, none of this is even recording. But, um, oh, hi. I am doing well. And, I'm glad I didn't make you wait. I saw the chat move out of the corner of my eye. Hello. I am doing quite well. These circuit boards, which are very simple, these are Hall effect commutation boards for brushless motors. If I'm not mistaken, I think these go into a medical centrifuge. Those are the actual Hall effect sensors. Normally I have, well, I say normally, this is the first time I've run this camera setup. I'm gonna try and get a still here. Nope, just stopped working altogether. I have a microscope view that just doesn't want to work. Let's see. It's gonna work. No, it's not. The last time I had to remove the view. I'm gonna add a source. Yeah, right. Let's see. Let's just try this again. All right. Okay. So unfortunately, when I do get it to work, it works in so much as it takes stills. Yeah, it's frozen, but you can see the details at least. So those are the Hall effect sensors. There would be a circular magnet that's attached to the motor shaft, and each of these sensors will detect where the north and south pole positions are on that magnet. So as this magnet rotates, it can get a very precise position of the motor's rotor. And then there's no electrical connection to the rotor. It's just all permanent magnets. And then the stator, let's see if I can. Yeah, it's stuck. So the stator, there's different windings around. So as it detects the magnetic rotor rotating, it's going to electronically drive the different coils to kind of create a rotating magnetic field from one coil to the next, and that will push and pull the magnets of the rotor in a circular position. I realize I'm spinning my mouse and you can't see that. So, but yeah, it works quite well. Let's see. So, yeah, I set up a bunch of these. These are iPad LCDs. I've got 4 of them total. 2 of them in these panels I have. Oh, why is my face cam frozen? All right, I broke something else. Nice. Okay, there, that's fixed. All right, so I've got 2 of these iPad screens here, and then this is my bench monitor. This is homemade, so this is also 2 iPad screens. If I rotate this, you can see it's literally just layers of like polystyrene plastic cut out in patterns to house everything. Literally just screwed the layers together. But that is my primary workbench display. I can slide it side to side, tilt forward and back, rotate. And then it's not set up yet, but I have some cable chain that I'm going to run along the bottom edge of the top shelf of my workbench. So all the HDMI, power cables, and everything will run through this so that I can slide this and not have this absolute tangle of wires which is hanging everywhere. So the end game is having this all contained. No, the touch capability is not there. I just realized half the chat is off the screen because I made room for working on my OBS. But yeah, so I've got a desk that way that I'm going to use these 2 monitors on, and they're going to mirror what's on these. It's an old computer. It's built from all recycled parts, but it's a 10th gen i9, 64 gigs RAM, Radeon 7. That I'm going to have two HDMIs from that GPU feed into these splitters. It's just a simple HDMI splitter. Oh, hi, Tam. Hi. Come on. Come on. You going to come up? Cat. Tam. Hey, buddy. Come on. Come on. Cats. You going to come up? Oh, hi. His favorite pastime. Ow. You're a goober. Ow. He really likes chewing on me. It's his favorite thing. Ow, that actually hurts. Dude, stop. Ow. 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 Stop. That's not very nice. And there's witnesses to your crime. Of course, he's hanging just below the screen. Oh, you fell off, didn't you? So, yeah, that's my life. He is about 9, probably 10 months old by now. Don't know exactly how old he is, but just estimating about late 9, maybe 10 months by now. He weighs over 10 pounds. I forget what that is in kilograms, I think. Is that 4.5? Oh, he's still learning how to chew on me in new and creative ways. Got me a little hit. You may be able to tell it's his favorite pastime. Oh, I'm looking at the microscope. Yeah, I am just, yeah, this is my life. Cat distribution system. Um, my sister's best friend was gardening back last May, and this little gremlin crawls out of a bush, and she's like, "Oh, you're so cute." Goes and cuddles him, pets him, the whole thing. And once, he figured out she was okay, the rest came out of the bush. 4 kittens total. It took her a month to find homes for all of them. He picked me. He saw me and just immediately approached me and was like, "I choose you. I own you." And I'm like, "This is my fate." He is super social too. I've never seen such a social cat. His first time at the vet, he was licking the vet while he was getting his first shots. Yeah, he just is completely nice to everybody else. He knows he can get away with it with me because, I'm a hopeless cause. He owns me. What can I do? I know. Yep, exactly. So, so yes, I'm doomed for hopefully a good long time. Oh, hello, are you back? You're adorable. Did you know that? Anyway, you got to see the goober, my house gremlin, and I have 4 boards left. and see if I can arrange a surprise here at the end of the stream. I've got a tool that I really like, and it was one of those on a whim purchases when I had a bunch of surplus cash. It's like, I don't need this, but I want this. And I will absolutely end the stream with a little fun. Not quite there yet. Like I said, I only have 4 of these boards left. Well, I have 25 more that I haven't started, but I'm doing these in batches of 25, just, because workbench space. It's hard to see because obviously the camera is top-down view, but the whole workbench, just in general, let's see if I can find. Let's see if I can find some pictures here. Actually, yeah, that is the goober posing. This was when he was just a little guy. But yeah, trying to find some projects here. Oh my goodness, my phone is so unorganized, it's ridiculous. Getting close. So this here, it is my computer desk. It is custom built, as a top shelf, an upper tier, main tier, made from red oak. Can I do screen share? Is browser. Let's see if I can make this work. So you've seen display capture, maybe. All right, that'll do. All right. So this is my full screen. There we go. So this is my desk. I built this in 2004. 2024. Good Lord, it's not that old. So this thing in the middle is the chassis from a old Harris Stereo 5 radio mixing console that I got from a local radio station. That's my monitor, 49-inch LG. I have another. I like ultra. Ow! Oh! Oh man. Ow. Ow. Um, you missed that because I didn't have that up. I just had him try to climb up to the back of the chair. You little goober. No climbing me. He did get me. So, I keep trying to scroll OBS. So, this is kind of the concept that I'm going for. I'm a Kerbal Space Program fan, and I'm building flight instruments into the desk. There's my keyboard that I made. So that's the old radio console. So this is what it originally was. Um, these are some of the instruments. So I have a flight director attitude indicator here. I kind of built this LED display module myself. This is kind of inspired somewhat from the old Apollo Disky. This is modeled after the vertical velocity meter in Kerbal Space Program itself. And then these meters were actually from old power plants. So these are meters they used to use in power plants for various readouts, and over the years they've been replacing them with digital ones. So you can get these surplus. So that's the keyboard I made for the Disky, also inspired by the Apollo one. This is an old video mixing board. I actually pulled this fader, this T-bar fader off of there. I'm going to be using that as my throttle. I modified all of those power plant meters to look like Apollo meters. This tape meter is built from an old piece of 1960s test equipment. That's actually like a belt running back and forth through rollers. And these numbers actually physically scroll past here. The original one had a window in the end and showed one number, but I milled this opening to kind of mimic the tape meters that were used on like Apollo and Space Shuttle. Again, this is kind of what that looks like more close up. That's just sort of some random testing. This one's fun. This is my ROM. Oh yeah, you can't see that. Here we go. This is my ROM for the Disky. See, I'm gonna turn the display capture back on. See how these units of measure are being displayed kind of separately from the numbers? Well, this ROM that I built using diodes encodes all those digits. So it's hard to see kind of all the details, but this is essentially what's in a ROM chip, but in individual single components. I've got a better picture of that too. Although, while I'm at it, I might as well just pull this down. So this is the Disky, and as you can see, I got really good at making these ROM modules. I got these to a point where I can make these in a day, like a single afternoon, and they're small enough. This is my first one. It's kind of crude, it's wide, it takes up a bit of space. These ones, I built them so compact, and I don't know if you can tell that, but the entire structure fits within the width of a standard chip socket. So I could use standard chip sockets for these and put them side by side if I wanted to. They stack neatly. Um, but yeah, so this is the actual display. And, that was a fun project. Um, what wasn't fun was the first batch of displays I bought had worse than 50% failure rate. Um, oh, I was so mad. Got them from China, of course, AliExpress. They show up, and within days, half the segments are burned out. I kid you not. I ended up replacing these with proper, like, not just, you know, AliExpress bargain bin. I actually ordered these from, there's a place called DigiKey in kind of northern Minnesota. They are like one of the global premier parts uh, suppliers. Um, Highly recommended. Um, but yeah, so I replaced all those with proper displays. At one point, at first they sent me red displays. I ordered green, and I kid you not, they said description green, circuit board is green. I kid you not. They tried to like get out of that mistake by saying the circuit board was green. Like, I ordered green LEDs. Yeah. And then so I get the green LEDs, and that batch, I think it was 58% of them failed. And I was like, no, I'm done with this. I got a refund. And that's one thing I'll give AliExpress credit for. They know they sell cheap Chinese stuff, and they want to have a reputation of actually backing their buyers. So they're usually pretty good. Like if a seller cheats you out on something, or they don't ship it, or they send you junk, they're pretty good about actually refunding it. Um, I've had better luck with AliExpress than Amazon. I'm not even joking. Um, but yeah, this is my first one, the one I showed you. You can kind of see it in a little more detail, but for size comparison, I think that's pretty small. That's my little time 2 one. It's only got 4 digits encoded, which is why it's so much smaller, but like just on a standard coin cell. So yeah, this is a good comparison of my streamlined design versus the original one. But yeah, I believe it's the nice thing is a 0 is encoded with no part at all, and a 1 is encoded with a single diode. So if you combine all the zeros and ones together, there's 208 bits of data encoded in this little structure here. And you can kind of see there a little better how I got it so narrow. I actually mounted the diodes at 45-degree angles. That way, you know. See, and that's the thing. I'm 100% a hardware guy. Me, I will sit there and build this hardware like I just drew a little diagram for what I wanted to do on paper and built it. Going back to my desk. Whoa. This desk, this entire design was done with 3 measurements on a scrap of paper. All of this design was done on the fly, pretty much in my head, with, like I said, 3 size measurements as references, like for desk height, things like that. That's how my brain works. So yeah, these angles here for this part were all just kind of figured out at the table saw. Um, so this desk isn't built using, I guess, traditional design methods. Um, this was built in a way almost like how a 3D printer builds things. Every piece that I designed and cut was an additive component that attached to something that I'd previously built in the step before. So this was just kind of a process of, all right, I need legs next. I'm going to build that and measure it to what I need for this particular moment, and that's that. It's a weird way to build things, but it works. I have no idea why so much of my text is white. I have no idea what's going on there. Because it's not a selection. Weird. You know? So these joysticks, you can get them cheap off of eBay. They call these a 4-axis joystick, which is a dumb name. It's a 3-axis joystick with a button. So obviously there's up, down, left, right. They rotate clockwise and counterclockwise. Then they have the button. Originally, I was going to have 2 of these joysticks, but then I remembered this from my childhood. This goofy looking thing is a Fairchild Channel F controller. It is probably the weirdest video game controller in history. You hold the base like a pistol grip, and then you hold on to that knob on the top like a doorknob. But this thing came out, I want to say, was it 75 or 76? That knob, you can push it forward and back, left and right, but you can rotate it clockwise and counterclockwise, and you can push it down and lift it up. It is a full multi-axis, like it's a full 3-axis. Technically, I suppose this has 4 axes. It's a whole axis more than these eBay ones. Yeah, like it's an impressive control. It's only digital, it's not analog, but that's fine because the space shuttle and the Apollo used a controller similar to this. The shuttle especially. The only difference with the shuttle is theirs was a square knob instead of a triangular one. Literally, that's the difference. Also, this has one more degree of freedom than the space shuttle one had. So the shuttle had up, down, left, right, in and out. This one also has rotation. So I'm going to be using this as the translation hand control. On Apollo, what that did was, if you ever see like videos where obviously you got the rocket to thrust forward, but you've also got the little jets all around that let you position the spacecraft. That's what this would control. And so the fact that this old Fairchild Channel F controller is so similar, like I have to do that. I have to go with this. I had one of these as a kid. I did take it apart eventually because, let's be honest, it's not even as advanced as an old Atari 2600. It was a very old machine, and it wasn't terribly impressive. It was the first game console with ROM cartridges, though, so it does have an interesting place in history. But I just got one of these off eBay to, so I could have one. I'm not even going to modify this. I'm literally going to make like a friction fit kind of almost slot that thing slots into. It's going to kind of clamp with some foam to kind of hold it stable. I'm literally not going to modify that controller. I'm just going to use it exactly as is. And it will be perfect for the translation controls. That's the insides of that T-bar fader. So I was experimenting with tint, like car window tint, to kind of create that weird, almost gold look for the old Apollo displays. Yeah, I'm glad to entertain. But yeah, this was just an experiment to see how it would look. I still got to tweak things, but I think this will be a nice, unique look. Um, so this kind of, so these are just space shuttle tape meters, and this is kind of the concept of how that works. Um, let's see, gotta, this is just, so this is kind of me modifying those. I get more into this later. This is one of my computer cases that I built. There's a Nixie clock, some old Art Deco kind of post box doors. Yes, yes, that was the belt I was talking about. Um, but yeah, so this is one of my computer cases. It's an old 1939 Philco radio cabinet. I got it gutted. There was no radio in it. So this was actually almost like a third taller. It was like 13 inches taller. I actually cut this down and reassembled it. Um, that's the Nixie clock. And then this little space here, I've got the tubes for it, but I haven't built the circuit for it. I want to build, I have a Decatron tube. It's basically this round tube with a bunch of points around the border. And they used them for old counting systems, like computing numbers and whatnot. And the glow will actually jump from one pin to the next in a circle. I'm going to turn that to my drive activity light. So it'll literally be a tube with a spinning point of light to show drive activity. Yeah. Okay. So this ends up being the design for the meters that I kind of settled on. And it's just some more refinement. Um, those are all printed using a laser printer. This here is actually, let me take the screen share away. So this is my Hall effect tester. When these have the wires soldered to them, they clip onto these little clips here. Yeah, it's just like a little slot there. You press that, and then it grips the wire. But yeah, power, the 3 signals, and then the lights show that it's working. So I have a little of everything in this house. My folding at home computers are all running Linux Mint. My main computer is actually a Mac Studio, and this computer is just an old 8th gen Windows laptop. So I'm running a little bit of everything. I'm kind of trying to delve into Linux a little bit more. I installed it on my PS3 way back in the day. Got really mad at Sony for bricking that in 2010 and never really forgave them for that. And I really didn't mess with Linux again for over a decade. I'm only just now kind of dabbling in it again. I installed Zorin for a couple customers of mine, and that kind of got me curious about Linux again. So I almost went with Zorin just because that was something that I had been, working with, at work. But I ended up going with Mint just because that seemed to be nice, I like my studio. It's still very powerful. It is literally the cheapest, lowest end studio, oldest generation they made. Like, they don't make a weaker one, but it still is a wildly powerful machine. Back when Power World first came out, I just emulated it. Not even joking. It's x64 code, DirectX 12, API for the graphics. I'm just running that on an ARM 64 chip under, emulation and translation layers and translating the DirectX 12 to Metal. Just emulated Power World. That's the oldest, weakest studio they make. I want a new one so bad, and then the RAM disaster happened. KiCad. I used to want to learn Eagle, but there were so many limitations with the non-professional, paid tiers. By the time I finally got around to learning circuit board design, I think Autodesk had bought Eagle and it's pricier, and I didn't want to deal with the limitations, so I went open source, went with KiCad, and I love that software. Um, but yeah, so there we go. So this is the first board I designed um, using KiCad, and what this is just it's literally this hall tester, but not hand wired. So yeah, so did a few tweaks to it, but yeah, that's the final board. I used some really nice components on there. This is also my first switching, uh, like DC switching supply. So this one here runs off a 9-volt battery and it's regulated down to 5 volts using a linear, like an LM7805 regulator. The casing for this, you mean? It's just a generic box that you can buy. Like I said, came from DigiKey. You can get project boxes of just about any size, and I just happened to get one that was that size. In this case, this thing, I got another project box. This one had AA battery holders. I only used 2 of them. And I have a boost converter in as part of this circuit. So I take the 3 volts from the 2 AA batteries and boost it to 5 volts. But everything is such low current that the 2 AA's will last far longer than a 9 volt. But yeah, I'm pretty satisfied with how that turned out. That's my keyboard. The keycap set is called Danger Zone, and it is absolutely inspired by Top Gun. In fact, on their second run, they were forced to not include the Danger Zone key because they kind of got in trouble. But yeah, let's see. The keyboard is hand wired and hand laced. And then I actually ended up rebuilding the number pad for it. Yep. Okay. I was experimenting with UV LEDs and these glow in the dark planet keycaps. There was another keycap buy that had those, and I was like, I have to get them. So yeah, this is funny. I was trying to make imitations of the old Apollo switches, and they have they're hermetically sealed. They have this kind of orange red rubber boot around them, and I ordered these off of AliExpress. That's what I got. These turned out much better, but in the end, I didn't go with any of this. I found an absolute so these are the original Apollo switches. These Honeywell switches, I kid you not, are like $300 a piece. They're insanely expensive. So my idea was put these rubber boots on and then 3D print the little tab levers and just epoxy them onto the end. That was my original idea, but I found something way better, which I'll eventually get to. So this is that tape meter next to the disky, and there's the vertical velocity meter, and I'm just trying to figure out where things fit. That was one of the first times I kind of brought everything together just for a test fit. Um, oh, I'm sure it would be great. This part here is what made my tape meter simple. This is an absolute position sensor. This will rotate continuously, and it'll put out an analog value from 0 to 5 volts, and when it gets back to the beginning, it drops back to 0. So one rotation, I can put this into an analog to digital converter and read an exact value. So this position is perfectly repeatable. So if I rotate this to any angle, I can tell the exact angle this is at. So what I ended up doing was I figured out that this drum, which the belt runs over, takes exactly 6 rotations to loop the belt back to the beginning. So what I ended up doing was I found some belts. It's literally 3D printer parts. It's literally like they sell this stuff to 3D printers. I found belts that had the exact ratio of 1 to 6. So then I can put that absolute position sensor on the big wheel. So this turns 6 times, this turns 1 time. It's a tooth belt. So this position of 1 revolution tells me exactly where in the 6 revolutions this is. So I can tell exactly what number is being shown on the pointer from this here. Yeah. So then I designed this little assembly to go onto a motor. Got the motors, tested them, made the assembly. I love this picture. Here I demonstrate posing in a work-like fashion. No one is fooled. Who is holding the motor? No one. That's who. No work is occurring here, like those faked fast food photos on the menu. I posed that picture, and then I realized it looked so stupidly absurd I had to just comment on it. But yeah, you can kind of see how this is all starting to, I have an adapter here for that piece, and that's the wheel there, and eventually all these bearings come together. So the reason there's 2 belts here is one belt will go to this wheel, then the other belt goes to the pulley wheel that runs the number belt. So this is going to be one of the things debating whether I machine this or 3D print this. It's definitely going to be one of those things that's going to be easier to 3D print, but I think I'm going to take this in a different direction. I could machine this or I could 3D print it, but I think I have a milling machine. It's a small one, but it does the job. I have a whole machine shop here. It's 1 by 2 meters. I literally have it in a closet, and to use my milling machine, I have to I open the door on the front of the milling table that it sits on. I stick one leg inside of the table, then the other leg hangs outside the closet door, and that gives me just enough room to use the milling machine. roomy, but it works. But yeah, so this was the concept that came up with. There is some tragedy here. I will get to it. So I cut these plates. I Oh yeah, these are fun parts I have too. These came out of that video effects board. They are smart displays, and I'm going to be making some extra readouts using these. Um, I had to cut one of the meters just to make room for some of the structure. Here's assembly of it. So yeah, you can kind of see how there's one belt that goes between the belt, the number belt drum and the motor, and then there's another that goes between those. And that there you can see the actual how the belt with the numbers fed through. Oh, what I was gonna say before is my where'd that go? This little thing here is meant to be the housing for my velocity meter. This is expanded later on into more. I'm I am half tempted to do a 3D model of this, and instead of machine it myself, order it from one of those places like what is it, like JLC PCB or PCB Way. I think they do. You can order metal stuff. I want to order it anodized green, since I like green just in general, and green is of course, the Kerbal color. So I want some of these trim pieces done in green, and I think anodized would look amazing. So that's what I think I might do that way. I know it's going to cost a little bit more to do it that way, but I think it's worth it. Um, but yeah, you can see there's a belt from the motor to that. Then there's another belt behind there that goes to the big wheel. That way everything is synchronized. And then that's one of the meters that sandwich between the 8 ball there. And you can kind of see how the motor just hangs underneath there in that gap. We use some pictures there. So this is kind of this console. So this, like I said, came from a local radio station. This little panel here, this, with the curved front, that is the cover of some 1960s test equipment. Yeah, this curved steel bar is from, I can't remember if it was the PS3 or the Xbox 360 demo stand at a GameStop that I used to work at. When they switched over to Xbox One and PS4, we took those apart and I kept some parts out of them. And that's what this is. I think it was the PS3 one. I'm not sure. I can't remember if it's PS3 or the 360. So I made some different colored LED annunciator lights for that disky thing. This here. This is the tape meter. So you can see how the tape moves. I got the gear ratio pretty good. I realized I was making noise. So this piece is going to be the radar altimeter. I have a stamp set for the Futura font that's used on Apollo and the shuttle and all the equipment that NASA has. Part of me wants to build a jig, get some white ink, and just make a whole tape with the proper numbers, and the other part of me is terrified of that prospect because I only have two of these tapes. If I mess up one of them, I only have one left. I'm tempted. Oh my goodness. I hate the algorithm. So this is me getting into modifying the meters. Yeah, YouTube is such trash these days. But yeah, the amount of AI channels they try to feed is just stupid. Yeah, so that tape meter, shirt sleeve caught it and it hit the floor. I have to rebuild it. Yep, it hit the floor and everything got warped and bent out of shape and it doesn't work. That sucks very much. But yeah, so these lights, I literally milled these to shape and like made them to what I needed. Yeah, here's the thing. Here's the thing. AI, it's got uses and then it's got abuses. I actually have been following kind of the AI scene since like 1991. I'm not even joking. Um, I let's see if I can find. Whoa, where? Oh, I see what's happening. It's overlapping the screen. Um, that's dumb. Thanks, Microsoft. What do I need here? Maybe I should stop the overlay while I'm searching. All right. All right. So this should be safe. All right. So back in the back in the early 90s, late 80s, this person was working on a literal silicon retina chip. They were doing binocular stereoscopic vision using neural circuitry basically in like 1989, 90, 91. Oh, okay. Yeah, yeah. There's actually a documentary. You can find it on YouTube. Oh, can I please, like, I I really despise this site.
Misha settled into Oxford, she lost momentum.
That. Chips. I remember, like, some of the old ideas were just so unique, then. This was like cutting edge back then.
For each eye and one for the stereoscopic.
But yeah, she had two different video sources. Nice, nice. Yep. Yeah, I saw this as a kid. Actually, my dad ended up in the hospital, farming accident, injured his knee, and he was, he was bedridden in the hospital for close to a week or more. And basically, I'm sitting there in the waiting room, spending time with him there. They got magazines. They had a Scientific American and a Discover there. And I learned about Rodney Brooks and the MIT leg lab back then. And I learned about her, silicon retina. And yeah, I mean that was pretty cool. Um, yeah, I've got a copy of her book, or basically her thesis. That is usually a very expensive book. I tell you what, I actually watched for years and managed to catch it on. I know sometimes with like different listings, they'll be algorithmically determined, and I managed to get her book for like $13. It normally sells for like over 100, I believe. Um, but I was pretty happy finding that. Um, oh, that's not right. Okay. So, put that to that. But yeah, so interesting little side journey there. But yeah, I was fascinated with that stuff as a kid, and I if I got it here somewhere. But yeah, I'm gonna go silent for like a minute. I'll be right back. Give me a moment. All right. Okay, so yeah. Oh, I'm not sharing my desk. Sharing the desk would help. So I got Misha's book. This is a fascinating read. Carver Mead's book as well. Yeah, thanks. Glad to glad to entertain. And if you look at my logo, my icon, whatever, that is based off of Randall Beer's little cockroach simulation. Let's see if I can find that sucker. Gotta have the whole thing here somewhere. Come on. I don't know where it's at. Oh yeah, go for it. That's fine. Clips, screenshots, whatever you like. Contents might help. I've been fascinated by the AI stuff for a long time. Okay, Euromodel 49. Oh, this, I think they're talking about the actual neuron model. I need further down. Results 80. Stinker. Okay, there is a hot soldering iron right next to you, so be careful, Goober. No, Tam. Nope, 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 nope. Oh, you little stinker. Please don't eat me. Ah, hey. Don't bite me. Goober. Ow. You see what I deal with? This cute little goober eating me. Ow. You go down. Ow. I'm giving attention to something that's not him. That's the problem. Also, the problem is I'm giving him attention. So, you can see my dilemma. Little goober. So, I can't remember if this book has the total neural network or just, well, here we go. I'll just do a search. All right, here we go. So this is the neural model for Randall Beer's little cockroach simulation, and I learned of this way back in 1991 and thought that was the coolest thing, and eventually got the book. Yeah, it's really interesting because it has different behaviors. It'll seek food, food. basically energy sources. So I think it was simulated in, was it an old Atari ST, I think? Yeah, it's kind of an old school setup, but that is kind of neat. But yeah, there's different types of interconnections. This is my original drawing from when I was a kid, based on, I kid you not, uh, there was a little tiny photo in a Discover magazine that I think was about 2 by 2.5 inches in size. It was tiny. I could barely make out the details of it, but I just got a magnifying glass and kind of worked it out. Um, but yeah, I've had a fascination with like AI stuff for a long time, and it's genuinely cool what you can do with it. It's just frustrating seeing, you know, a dozen companies try to monopolize all the memory and all the processing capacity, and try to force AI, into everything. Oh, so speech, huh? Okay. If I remember, Broca's, that's kind of speech related, and then mirror neurons kind of, yeah, that's kind of modeling, um, like, yeah, I know what you're talking about, kind of. Yeah, this stuff is fascinating to me. Old phone part. Yeah. Okay. Told you I'd have all the fun stuff at the end. I'm not even done. Dude. Oh, that's right. The battery connection is all flaky. I don't even have the screen on. Alright. Please don't knock my files over. So this is neurons. There's no computer in here at all. It's 16 neurons to generate a walking gait. Orientation sensing. Literally coat hanger wire and a colossal amount of flux. It's not welded, it's all soldered together, and I built this, oh my goodness, this was over 25 years ago. I'm going to push these back a little bit because I don't want to deal with that disaster. So it's not very smart. It just kind of walks in a straight line, and it's got a few things that are out of adjustment. Just it's literally made of junk. So this piece here is the metal shield from that went around a flyback transformer in an old portable TV. This side would have mounted to the circuit board, and the high voltage cable would have come out there. The motors are from a surplus store. I don't think they're even around anymore. There's a place many years ago called BG Micro. They were really popular for a while with robotics hobbyists because they had gotten a huge surplus of these security camera pan and tilt mechanism. Okay, all right, cool. So these are the old BG Micro motor, as some hobby communities used to call them. It was a little gear motor, and it was just perfect for robots like this. All the boards are hand etched. This is the neuron board, so this is kind of the brain. There's a 4-core central pattern generator on this T part of the board. And then there are 4 branches of 3 additional neurons each. And with the central generator and the 3 neuron branches, those generate the gate patterns for each of the legs. All of those run down these wires. These are literal old buried phone cable wires. I had an uncle who was working for the phone company when they first installed the internet trunk lines between towns, back when they installed internet back in like 95, 96 in where I lived. And so this is actually all old copper phone wire. But yeah, all these wires here kind of bundle together through here and go to this filter board. This board locks out invalid outputs and only allows valid outputs to pass through. So even if this neuron circuit glitches out, it won't like short out any of the motor controllers. Actually, this thing likes to saturate sometimes, and for the longest time, the way to get it to not saturate was to just literally blow on it. Like, just a little bit of moisture was enough to change the analog aspect of it to make it work. I actually dunked this whole thing in an ultrasonic cleaner. I cleaned the circuit boards, and it's been behaving a lot better since, but it does sometimes still seize up. But yeah. It's technically a dumb gate. It only has one pattern sequence. Is that legs? Oh, because that's joints breaking. I will have to fix that sometime. I was wondering why that was hanging so far out. Anyway, like I said, it's literally made of junk and surplus parts. But this circuit down here, if you think of this as the brain, you could think of this almost like the brain stem. These wires come up here. Every point on here is actually socketed. So if I wanted to, I actually originally designed this. I never did make anything to take advantage of it, but I have actual control lines on here where I can rearrange part of the gate sequence. So I could, if I wanted to, add sensors to this that could make it do things like back up or turn. And it's just one of those things I never got around to because I just thought, well, I'll just do another one, you know. But it's also been like 25 years. It's one of those, I'll do it someday, and then like a decade and a half goes by, you know. But yeah, this is Spider, which is a perfect name for a 4-legged thing. It has 8 motors, so I'm cheating. Um, my naming is very, very unoriginal. Um, so this would be what would back in the day have been called a beam robot. There was a guy named Mark Tilden, used to work at Los Alamos. He came up with this idea of doing very simple robots that complete tasks in swarms. What is... Okay, hold on. Huh. I was getting a lot of background audio going. Huh. Weird. Anyway, I hope that wasn't interfering or anything like that. Yep, yeah, stuff like that, indeed. Um, but yeah, so I was really into like the liked stuff. Can you tell? Let's see. But yeah, this was kind of the last major robot that I built. Um, I've got some smaller ones, simpler designs, but this is kind of like the king robot, that I did. Um, but yeah, always liked this little one. I wouldn't mind doing some improvements to it someday, but it's one of those things that it's so old. I kind of... Oh yeah. I was showing the robot. Now I'm put that aside. So now I will return the screen. But yeah, so that was a fun little tangent. I actually I actually got some local AI models on my Mac that I'm hoping to use. See, you mentioned before you're a software guy. I am a hardware guy. I can build all sorts of things in hardware, but get me in front of software and I'm like, oh. I've always kind of described it as, for me, software is the homework of tinkering. So, like, I enjoy it if I like get progress on it and get things working, but I don't know it well enough to like just spit out code, you know. So for me, hardware is my medium. That's why I literally built diode ROMs when I could have just done it in code. But that was fun for me. So, okay. Neato. Alright. Okay. Oops. So yeah, like this whole project, I'm gonna skim through some of all this construction. You can see like there's light shields and things like that. Um, but ultimately, okay. Well, good luck on that. Here I got a little bit of needle motion on that, testing things out. That's my atmosphere meter. I actually use different colors of blue LED to get like that gradient here. I think there's like 3 different colors of blue LED and one that's kind of violet. And then, so all my backlighting all my backlighting, I'm using these sort of aquamarine teal kind of colored LEDs. I got them from Electronics Gold Mine. I don't know if you're familiar with that surplus place, but they had a bunch of these kind of blue green LEDs. I really liked that color. With Apollo, everything was backlit white. And I could have just mimicked that, but I didn't want to. This, while it's heavily inspired by Apollo and to a lesser degree the shuttle, it's still Kerbal based, you know? And of course, I like green. I like the whole Kerbal green theming. So I'm trying to fit little bits of green or off green, you know? So in this case, I went with this color for all my backlighting. I think that feels a little more closer to kind of that early 90s electroluminescent. But interestingly enough, the Apollo lighting is electroluminescent. Um, it wasn't like incandescent bulbs or fluorescents. It was actual like EL panels, and it was just very early technology back then. The panels were only good for maybe a few hundred, maybe 1,000 hours or so before they'd start fading. But like a mission wouldn't last that long, so it didn't matter. Um, their panels glowed white, but I'm choosing that color just to have a little bit of uniqueness. This was the um, backlighting for the Legend panel, and then I built this light shield to create a clear dividing line between the upper and lower halves of that. And then this is my gradient panel with the different colors of LEDs. And so each of those panels, and then there's another one to shield that one. This material is weird. It's not copper sheet. It's actually an incredibly thin circuit board material that's plated on copper on both sides, but it's so thin that I can bend it, it takes shape, and it's really easy to cut. So I literally just cut it with a scissor. But yeah, it's basically a very, very thin layer of circuit board with a layer of copper on the top and bottom. And it worked perfectly for the task. But yeah, you can kind of see how I got the backlighting in the one color there, and then I have my atmosphere gradient scale on the bottom. This is one of those things that'll never be seen, but I kept the label just because I wanted to. This would have been a utility company, probably a coal feeding thing. So there's the big picture. That's every meter fully illuminated, fully functional, completed. These didn't even have backlighting when I started with them. Like, not even kidding. These were not backlit meters. All that's custom built. So this is an actual photo of some of the Apollo meters. This would have been from the lunar module. And so they had a few of these kind of round style ones. And in Kerbal Space Program, they have that style meter as well for the vertical velocity. So that's what this one is. So in order to make things work, I actually heavily modified this. Came up with the design. In the lunar module, the contact light is the only blue light in the entire Apollo vessel. Every other light is white or some other, like, I don't know. I don't even know if they had red ones. Every light tends to be white on Apollo. They call it Christmas tree effect. basically kind of almost being blinded by just too much information. So in the Apollo instrument panel, instead of lights, they had these little barber pole indicators, which were completely reflective devices. They didn't emit light. Um, there were there were only a few things that they had be done by light, and the contact light was one of them. It's a just this big blue light. It's like you've touched the moon. I think that was really cool that they did it that way, and I've actually incorporated that into this meter. So I'm taking one of the internal structures. I just use a little hand drill to drill holes for the backlighting LEDs. So there's my backlighting. And then I've got two sockets for those two LEDs. There's my big blue one. This red light is the am I gonna die light. If this light is lit, you're coming down too fast. You don't want to meet the ground with this red light lit. And the blue one, of course, lights up when you are on the ground. So this is my velocity meter. These displays, I spent way too much for those because I wanted them to be unique. These are $10 a pop. These are some old mid-70s military surplus kind of things. What I like about them is they have an oversized green element, and it's a 4x7 matrix instead of the traditional 5x7 that most modern LED matrices use. This was a design that was only out for a little while. It's used in some military hardware, so they kept making it well into the 90s. These, I think, are 90s era ones. But yeah, this is actually a smart display as well. You feed it a binary code and it displays the appropriate number, and then the decimal is just on and off. But yeah, so I wired these up. I just love the look of these displays. Spent $80 on it, but it was worth it. So I did kind of a stop motion using dip switches here to send the number code, the binary codes to these to test them all. Yeah, I love how these look. And then my units are going to be displayed on one of these little smart displays here. Okay. I'll check that. Oh, sorry. I'll check that out. But yeah, so I do want to find a bubble display. Obviously not a red one, but I would like to find some kind of bubble display to go over this to make the numbers a little bit bigger. But yeah, this is the socket that I wired up for them. There's a shared data bus to address all these, and then there's an address bus that picks each individual one, and it's all just controlled by a few lines here. I left the back of these open because these actually get pretty hot actually, so I'll have some thermal grease and a little aluminum block behind them to keep them cool. And this is just some chip information I found for the my controlling my little ROM chips here. Not chips, the diode arrays. This was someone else's project. They took apart one of those nav balls, just like the ones I have, and they're actually controlling it directly. I'm doing things differently. I found this circuit it's originally from an old magazine, but it's a power supply designed to power up those nav balls. I ran into a guy online who does like AC power design, and we came up with this design, have a modernized version of that old circuit. And the way it works, you feed it the high voltage into here. It creates, plus and a minus DC rail, and then there's a reference input. So you send like a sine wave into here, and it will create a proper sine wave at the high voltage. So what I need is 120 volts AC, but at 400 hertz. That 400 hertz is what's used in aviation. So this board is what lets me do that. This is basically a sine wave inverter. So AC power, sine wave input, sine wave at AC power output. So all 3D renders there. This is another thing I found, and I'm so glad I bought these when I did. These came from Ukraine, which obviously things aren't great over there right now. At least I sent them a little money before things got bad. But these are absolutely tiny LED bar displays. For reference, this is 5 millimeters, this whole length. These are half-centimeter displays. The gap between it is a half-millimeter thick segment, and then it's 1.6 millimeters tall. These are tiny, tiny segment displays, and I bought a lot of them. There's the actual board assembled, mostly assembled. We actually discovered a defect in the design. It wasn't any of our faults. The 3D model and the schematic for the voltage regulators, the voltage regulator here, had the plus and the minus reversed. I kid you not. We caught it before any power was put to it, and I did fix it. This is a heatsink from an old G5 iMac. This was not on purpose. Check this. That lines up. I know, right? Yeah, I am really glad that I caught that. But yeah, I cannot believe that this board we picked this size board just completely arbitrarily, and it lined up perfectly. I don't understand how we got that lucky. But yeah. I did have to desolder all the tall components and solder them to the back of the board, because originally what I was going to do is have the transistors or the MOSFETs sit upright and have heat sinks on the side. But since this worked, I could put them on the bottom, but I had to reverse the orientation of it. And to do that, you can't just rotate the part, because then it's in backwards. I had to mount it from the other side of the board. That flips the part without rotating it. So I just resoldered all the components on the back side of the board, and it worked. I have these silicone pads putting pressure down from the board onto the part, and then there's a little thermal compound and ceramic insulators so nothing shorts. And then when it's screwed down, it compresses the parts into the heatsink. They get soldered in once everything's assembled, and it's one finished assembly. Yeah, this was the tragedy. My shirt caught this, and it hit the floor. it got absolutely wrecked. I had to buy a new motor for it because that jammed up the armature. The metal's bent up. I've still not fixed this thing. I don't know if I can even straighten this metal enough to where it'll line up again. It's just sheet aluminum. I can re-drill it. I can make new pieces, but it still sucks. That's pretty warped. You know, yeah. It's something I know I can fix, but I've been just putting it off because it's been one of those stupid things. This was a little side project for my mother. I built her a sewing table. Basically, the sewing machine is at the same height of the table, and then all the edges are rounded. Um, she appreciated that. And then this happened. So my power went out one day, half my power. Computer power's off, half the lights in the apartment go out, the other half stay on. I think what happened is this downspout was flowing over here for years and years. Oh, I haven't heard that in a while. Yeah, I think the water eroded out underneath here and it eventually collapsed because these things are heavy. It's not just a big giant transformer with coils of wire. It's coils of wire and then it's filled with oil for cooling. So, yeah, the power surge from when this happened destroyed my computer. I spent almost half a year stuck on a third generation dual core i5 tablet in 2022. Mm-hmm. That sucked. Fortunately, I was in the process of building a new machine and I had most of the parts already. That was that 10th Gen i9 I was talking about. Um, I did get a nice job and I ended up just buying my Mac Studio and that 49-inch monitor, and that ended up being my new machine. Um, I was actually having some back issues with my workbench. This is actually my workbench where I'm at right now. It's actually, I have side wings on either side. So like here's the main area, then I have wings on either side. So this is a wraparound workbench. You can also see there's a second shelf where I have like test equipment stuff, and then there's my dual iPad screen monitor, kind of just in the shot there. I didn't even unload the workbench. I literally got 3 car jacks and I jacked it up and I added extensions to raise the height. When I originally built this workbench, I built it based on the height of my old chair, which was an old car seat on a wheeled frame. And I just rolled that between my computer desk and the workbench back at my old place. But here, they're in different rooms, and I can't do that. So I didn't have a chair that was the right height anymore. You can see just how absolutely low this was. Um, so yeah, I literally just jacked up the whole desk and added extensions to it. So that's my 20th anniversary Mac. Not very powerful, but certainly a unique little machine. It's mostly a glorified music player. Oh, there's a good shot of the monitor in full. Yeah, I like this little computer. It was such a weird, quirky design for the era, but so that's the back of the monitor. It's literally just layers of polystyrene cut out in different shapes with different openings for different things. I'm not even joking. This grill here, this was a Walmart coat hanger. Not like you know how some clothes comes on like a little hanger. That's what this is. Just like a clothes hanger. There's my cable chain with cables actually wired into it. So that's just like a closet slide and a GoPro mount. Kind of see how the layers make room for the boards and everything. But yeah, again, just additive construction. I love additive construction. It's such a great concept. So that's an Apollo Disky. So you can kind of see what I was inspired from with that work I was doing before. So I found these switches at a Tractor Supply in my local town. Um, this is Case New Holland Industrial. So usually the blue and the red tractors, if you ever see those out in the country. At least here, you know, where I live. These are shockingly similar to those Apollo switches. So I literally bought out every one they had. They were kind of expensive. One of the switches was $40 and the other was $60. So they're still expensive switches. But, you know, I got 3 of them now. So that was an interesting intermediate step to getting some Apollo-like switches, but I still didn't have enough. This was me buying a second nav ball because I didn't like the idea of having just one and hoping that it works. The second one, I don't know where it came from. The first one, I know exactly where it came from. It was pulled from a Phantom flight simulator that was in Israel. People actually didn't bid on that one as high because the shipping was higher because it was international. And I'm like, you know what? The normal price these go for is usually so high. I'm just going to bid on this, and no one else bid. I'm like, shoot, I got it, you know? So I was happy with that. That's the studio when I first got it. That was my old desk. Literally just like 2x8s and 2x4s and some pine shelf panels and things like that. It was utilitarian. It did the job, but I decided it was, you know, time to make something nice. I wanted something nice to have, and that's when I built my desk. These aluminum panels, I mentioned these came from like old 1960s test equipment. They're aluminum panels, but they're coated with, they have a laminated layer of plastic, but the plastic is textured like faux leather. So I love it. It's completely fake, but that's exactly what I'm looking for these panels. It is like is as 60s as you can get. That's exactly the look I was going for. So I do like that they have the nice rounded front edge too, you know. That is not great cable management. That is a horror show. This is me starting the desk. So the first thing I did was I built the right and left side sections. And that's how the instrument panel kind of fits into it all. But yeah, it's just these pocket screws to, you'll notice there's almost no screws anywhere on this desk that are visible. It's all hidden either underneath or in the back, more or less. Um, so just building up more of the sides. I kind of cut this little weird shaped bit for the front. This is just like floorboard trim. Um, but the way I assembled it, you know, I made a nice leg out of it. And none of this was any more complex than what you can do with a table saw and a drill. Um, there are exposed screws on the inside of the legs, and the reason for that is I have electrical stuff in here. I want that to be accessible. Adjustable feet on the bottom, sliders for the desk. I started out with this darker stain, and it was too dark for my tastes. And I thought about like sanding everything, and then I thought, you know what, I'm going to try a few different things. I ended up sticking with darker stain on the vertical beams. And you can kind of see how there's the vertical beam, the desk segments. This is a fully standalone piece. And the right and the left half. All right. Well, you have a good rest of your day. Here we go. This is what I end up doing. I sanded down the dark and I stained it with a lighter color, and I end up loving the two-tone. So each of these halves, they're standalone. There's a frame that goes between that connects them together. And ultimately, in the end, there's no single part of this desk that can't be carried by a single person. So this is the frame that goes across. That's removable. The top shelf is removable. My measurements are spot on. This piece here and this locking peg here, and everything lined up to within about 0.5 millimeter. But yeah, everything is modular. It can all come apart. The top piece, you know. So yeah, that's kind of before all the staining. I can literally install the top piece single-handedly using nothing more than a clamp to support the weight of it. And then I can put all the bolts in. Yeah, like this whole thing, this piece here is a single assembly. So this panel here, and then these two cross bits, those unbolt, and that separates two halves. But yeah, that's the cross frame piece by itself. But yeah, I think it turned out pretty good. And I babysat it for hours till like 3 a.m. because you'd see all the little dots in the background. Those are bugs. And I had the air nozzle, and I blew them bugs away every time they got close to the finish while it was curing. But yeah, I really liked how it turned out. But yeah. Whoa. These are the switches I got. There's a machinist in Massachusetts who makes these, sells them on eBay. They are almost perfect replicas of the Apollo switches. You have a good night. All right. You have a good night. Thanks for stopping in. All right. I'm just about finished with these. Like I said before, I only have 4 boards left. 4 boards and some tangents. I'm gonna finish these up. Don't know if you're gone yet or if you're still there, but you have a good rest of your day or night. Thanks for stopping in. I keep forgetting I have a microscope camera and a screen. I don't have to strain my eyes to look at these. It's going to take time to get used to. I am doing it again. Old habits are hard to break, I tell ya. Every time that tip goes onto the board, I want to look at the board, not the screen. As long as I move things linearly, I can generally adjust for lack of depth perception. Two left. I'm going to call it a night for soldering. After I finish these two, I am doing it again. It's funny how hard it is to break that habit. One board left. I still technically have 25 more boards to do, but I'm going to do them in two separate batches because 25 is about the limit of what I can spread out on the desk and actually work on at once. More than that starts to get crowded. I am still looking at the board, not the screen. Didn't like the finish on those two. Sometimes it helps just clean the soldering iron tip, get fresh solder, and reflow it. Alright, turning off the soldering iron. Leave my fan going a bit to help clear out the air. But yeah, 25 boards, all effects are soldered on. Next thing that I'll do is I will mount the boards into the vise. I'm going to go ahead and adjust my focus a bit. I suppose you're not seeing this because the microscope camera. I'm just adjusting the microscope focus. Oh, hey. It didn't update the image though, so. There we go. So this is what I'd have next. There's 5 different colors of wire. These are some old wires. They're a bit tarnished, but you know, they go in to these pins, pull them back just a hair, bend them over to a certain angle, and then solder them. Yeah, there we go. So basically, I don't put them all the way in. I'd leave a little bit of exposed lead for some. I don't want the insulation all the way to the board, but they come off at a particular angle. Those get soldered. I flip the board. I trim the leads on the other side, and then I do a second pass with the soldering iron to smooth out the solder joint from the bottom side. I would then wrap the wires up in kind of a tight spool, you know, something about like that. Do like 2 wraps. That's usually pretty good. These then get washed in alcohol to clean up the flux, and let those, once that's all done, I would test them using the Hall effect tester and a magnet that I spin through here. I do 100% test on these. Every single one gets tested. If there's any faults or defects, I rework them or replace parts. None of them go through without being fully, guaranteed 100% working. And my camera come out of focus. If I ever upgrade this microscope camera, I'm definitely getting one with. I want the ability to adjust the zoom level of it. This one is fixed. The only way I can adjust zoom is by physically raising or lowering the camera. I don't like that. I wish I had more control. If you look closely, I have some marks on the desk. This is the area of my microscope where it zooms in. And anything in this area is magnified. I wouldn't mind being able to say like do a half magnification or even get even tighter in to see smaller details. This microscope can't really do that. Like you can move it physically closer, further, and then just adjust the focus. But that's about it. Interestingly enough, this camera does have an adjustable zoom, but it's not a microscope. And I hope that's in focus. So that's a project for tomorrow. As for, oh boy, that's the phone. Didn't think that through. Got my parts stacked up on top of something here. This out of the way. I don't want to drop anything on that and damage it. So I have a bunch of parts on spools. These are just surplus materials, things I've had for quite some time. The spools, however, take up a lot of space, and I would like to get rid of them. I don't want to lose the label. I'm going to go ahead and turn off the filter. Whoa. That's right. So apparently, when I turn off my fume extraction fan, there's enough of a surge that it causes my microscope camera to flicker out. Weird, but okay. Just trying to preserve the label here. So 471. So is that 471? Oh, hi, Cam. I am going to contain the remaining Hall effect sensors. These would be for the other 25 boards, and not for Tam. You cannot have these, Tam. I'm fairly certain they'd be very uncomfortable coming out the other end. All right. Tam? Tam? Come on. You want to come up? It's being stubborn. Tam? Come on. I'm gonna pet you. Are you suddenly camera shy? You little goober. Yeah. Anyway, I'm sure he will jump up here at the absolute most inopportune time. House paper. Oh, yeah, he likes playing with paper. So this is just a roll of resistors. Nothing too special, but they are kind of bulky and inconveniently in the way. Let him play with some paper here. I am going to cut these off. Alright, that should be good. This is my little tool that I really enjoy using. So first off, let's find some bins. So just some old model trains. I'm going to use these bins for now just because they work. That's all I need. So as you can see, the bins slot underneath here. And I'll give myself a little more room. So to show this here, this is a lead former. You turn this crank and it pushes leads through on these tines. It runs them through these cutter wheels. And then back here, these are lead forming wheels that mesh up with those. The idea is you feed a tape of parts into here and they engage with the tines and it will cut and form the leads. Alright, so give myself a little room. I absolutely love the sound of this machine when it's operating. I'm also going to arrange these so they can feed easily. Okay, so I think we're good to go. I do apologize, I have to fish these out. Really? All right. Oh dear. Ideally, I'd have a way to have these feed away. Careful, buddy, you don't want to bite them. They're sharp. All right. Waste. You cannot have those. You can have the paper. Alright. And the end result is a bunch of resistors with cut and formed leads. No, don't mess with the wires. Uber. I have a few of these spools like this, and over time I just want to, cut a bunch of the leads. Sometimes I'll adjust this so that it doesn't do any forming at all. It just cuts the leads. That way I just have, ones that are just straight. These ones, I put a mild bend into them. I could put a sharper bend in, but I figure this is fine. I can literally just do that to adjust it to however I like. You can't do that. That's sharp. That's got little wires. You don't want to eat that. That's bad. And this is what living with a workshop and a cat is like. Come on. You're just gonna be camera shy today, huh? So I kind of want to do some more. This is fun. I like these things. And a little more paper to play with. At least he's enjoying that. Rather him play with the paper than play with parts. Alright, so back into position. So there's different adjustments on this to set it to do different sharpnesses of bend. You can adjust the width of everything. But all in all, it's just pretty straightforward. With these really thin 1/8 watt resistors, if there's any strain here, it will bend the leads before feeding them. So I do want to make sure that these are all ready to feed through. Again, that initial, got to get the this appropriately should be like bolted down, but I don't have it bolted down. So normally you'd be able to, use one hand to guide these out, and then the other to crank, but I don't have that luxury right now. Whoa. Yeah. But yeah, I like to end my streams using this thing because it's fun. That's an entire, that's like almost a quarter bin's worth of resistors right there. and all cut and formed in mere minutes. This thing were bolted down, it could go through that whole spool in mere minutes. Alright, well, I think I am going to end the stream. For those who visited, thank you. And I will probably continue soldering maybe tomorrow. We'll see what happens. But thanks for stopping in.